Now let's understand the Hadoop cluster planning part. How you plan your cluster. My cluster can be single node. It can be a small cluster, 10 nodes. It can be a very large cluster, 1500 to 2000 nodes, 4000 nodes. Right? So I may have varying sizes of my cluster. So I will have a decent hardware for my clusters. So the current misconception people have is, because we say Hadoop runs on cheap hardware. So it does not mean cheap, does not mean you can put any hardware. You cannot put a desktop. Why you cannot put up a desktop, for example? Desktops are not designed to run 24/7. They do not have that good cooling capacity. Their heat form factors are not that high. What does it mean? Components which you put into, let's say, your motherboard, they are not resistant to heat to running 24/7. Right? So you will have different components. Let's say server hardware will be separate from the hardware which you use in your desktop. So we have to take care of all those things. So we will understand that in this section. So let's take in case of name node. What will be the size of my cluster? How will I decide? How big can be my cluster? It is decided by the memory on the name node. Right? Absolutely correct. You got that concept, right? So we have discussed this. How you decide? Let's say it's a common saying, right? Many times you might have heard somebody saying that I'm running a 4000 node cluster or I'm running a 3000 node cluster. How you define that? What is the maximum size of my cluster which I can run? Right? So it is decided, when we say it is decided by the memory of the name node. So what exactly does that mean? Okay. So if you remember the concepts of objects, so I'm talking specifically in terms of name node. Okay. So let me explain you that. So now let's understand how big my cluster could be. Everything goes into name node. Means metadata will always reside on name node. Now the question comes, how large my metadata could be. So it will depend upon the memory I have on my name node, means the RAM. How big my RAM is on the name node. Right? So the rule is, for 1 million objects, I need about 1 gig of memory. Right? So what does it mean? Everything in Hadoop is an object because it has come from Java. Hadoop is written in Java. So the concept is object-oriented concept. Everything is an object. So when I say everything is an object, what does it mean? Everything in Hadoop is an object. So what is an object? A file is an object. A directory is an object. A block is an object. So all these things are an object. Right? Each object occupies 150 bytes of memory in the name node. Right? Each object occupies 150 bytes of memory in the name node. So what does it mean? Let's say I have a file 1.txt, which is equivalent to 128 megabytes. Right? I have a file 128 megabyte in size. How much memory it will be required on the name node to address this file. Means what will be the metadata size for this file on the name node. So now let's say my HDFS block size is 64 MB, which is the default case. Right? This is TFS block size. So this 128 MB will be broken down into 2 blocks. Correct? I will have 2 blocks. So 2 blocks means 2 objects. And 1 object for the file name itself. So total I have 1 for the file name, 2 for the block. So totally I will have 3 objects. So 3 objects occupy how many? 3 into 150 bytes of memory. So it will be 450 bytes of memory in the name node. So if I have to store a file which is 128 MB in size and it is broken down into 2 blocks, I will need 450 bytes in the memory of the name node. So the total memory I have on my name node, divided by this total blocks will give me the number of blocks or objects I can have. Right? So you got the point. So so that's why we say we discourage having smaller files. For example, if my block size is instead of 64, it is 128 MB. Let's say my block size is 128 MB. Now the memory on the name node will go down. Why? I will have only 1 block and 1 file. So now I will need only 300 bytes on the name node. So now total memory on name node divided by 300 bytes. I can have these many objects in my Hadoop cluster. Correct? So now the question comes, it is not about the number of data nodes. It's not the number of data nodes, right? So understand this point. I have a name node. I may have a case where I'm running, let's say 1, 2, 3, 4 data nodes, right? I'm running 4 data nodes, each having 250 gigabytes of hard drive. Each data node has 250 gigabytes of hard drive. So I'm just giving a round figures for the sake of calculations, right? In real case, your hard drives on your data nodes will be much bigger, but for the sake of calculations, I'm taking round numbers. So let's say each data node has hard drive of 250 gig. Correct? So the total storage is 1 terabyte. Correct? Another case could be, I have 1 name node, I have just 1 data node, and it has a hard drive of 1 terabyte. So the number of blocks are same in this case also and in this case also. When I had 4 data nodes, total number of blocks are same, right? In that case I had 4 data nodes, I here have only 1 data node. So when I say how big my cluster could be, it necessarily does not mean physical number of nodes. It means how many blocks I am representing in my cluster. I'm representing 1 terabyte of blocks. It does not matter whether it comes from 1 data node or 4 data nodes. So my total size of my cluster could be the total number of blocks I can represent in my cluster. So if I can represent, let's say 1 million blocks, 1 million blocks in my Hadoop cluster. So I will divide this 1 million blocks on my data nodes in terms of performance and distribution of hard drives. So that is deciding my size of cluster, right? So this 1 million blocks can fit in 1 gig of RAM on my name node. Metadata for that. So I have a question here from Archit. He's saying how reverse of this is true, that is, if I am having 64 gig of RAM, then how many objects it can support and how large the cluster is. Okay. So now let's take his question. He's saying my RAM on my name node is 64 gigabytes. So let's say our entire 64 gig is available for name node. So I'm making an assumption that there is no memory required for operating system. But in real case, if let's say if my total memory is 64 gig, I will count some memory, I will minus memory for the operating system, I will minus memory for the name node daemon itself, right? Name node daemon itself. So out of the 64 gig, my total available gig might just be 50 gig because my other daemons are using other things. But let's keep the calculation simple. So let's say 64 gig I have on my name node, making assumption entire thing is available for my metadata. Now, how many objects I can have now in 64 gig? Right? How many objects I can have? So let's say I decide my HDFS block to be 64 megabytes. Right, 64 megabytes. And my average file size is, let's say, 128 megabytes. So the memory which I will need per file will be 450 bytes. Correct? Because 2 blocks, 1 the file name. So this 250 bytes divide this by 64. 64 gigabytes divided by 250. It will give me number of objects I can have. So these many objects I can have in my cluster. So although in practical it will be much less than this number, but this will be the calculation. Correct? So this will be giving me the number of files, right? Number of files, this one. If I divide this directly by 150, it will give me the objects, right? It will give me objects I can have. So now it is very important for me to have a machine which has good memory. It supports good memory. In the case of a name node, 64 gigabyte. Here they have said 64 gigabyte, but in real production, I will be running much larger memories, 256, 5112 gigabytes of memory on the name node. Another thing, although we said that our systems, they will not use RAID, right? What is RAID? Let me quickly give you an idea on that also. So RAID is redundant array of inexpensive disks. So all those people who are not from system background, so let's say I have a disk hard drive, let's say SDA, I have a second hard drive, SDB, this one is of 1 terabyte, this one is also 1 terabyte. I can mirror them. So what does it mean? I'm configured this as my operating system disk. So whatever I write here will automatically be written here. So this is called mirroring. So it's called RAID 1. So this is what we do on our name node. So why we are doing on name node? Because the replication is for data nodes. Backup is for data nodes. Copies are made of the actual data 3 times, not of the metadata. So there are two options I can use. I can say Hadoop config HDFS -site. I can here give a comma separated field, right? Or I will put this on a hard drive which is in mirror 1, so that in case something goes wrong, I can recover it. Also, I will make sure that I have multiple cores, right? I have multiple core on my name node so that I can do lot of parallelism. So what does it mean, lot of parallelism? My name node has a parameter which is called handler count, which is equivalent to 10 by default on the name node. So what is this handler count? So the name node daemon which is running on my name node, right? The name node daemon which is running on name node, it is a multi-threaded daemon. So what it will do? It will run by default 10 threads. Right? It will run 10 threads. So the data nodes which are sending updates to name node, right? They are sending block reports. So my name node should be able to handle the updates which are coming. So if my clusters are small, let's say 100 node cluster, it is fine. 10 handlers are fine. But if I'm running larger clusters, let's say 2000 or 3000 node cluster, I will increase this handler count. Maximum I can give is 60. Right? So I should have multiple cores. So I can have parallelism. So I can run multiple threads. All these are multiple threads. So I should be able to run all this in parallel. I can do this only if I have multiple cores. So if I have a CPU with only a single core, there can be only one process which can run. Which can run means in running state. Let's say I'm using a system at home which is only having one CPU core, right? Which is having only one CPU core. So what will happen in that case? Let's say I have opened a web browser, some Word document, let's say Excel document. I am playing some game. So what it will do? It will do time slicing. It will give some time to this application, some time to this application, some time to this application. So if I execute PS command on my system, I will see only one process running at a time if I have only one core. So it is good always to have a CPU with multiple core. There will be one CPU die on which you will have multiple cores. So you can run a lot of parallel things. So this is one CPU die, CPU core, on which you have 4 cores. So this is a quad core CPU. So when I have a quad core CPU nowadays, each core is having a VT flag and HT flag. What does it mean? VT means they support virtualization. HT means they are hyper-threaded. So whenever I'm using a CPU from Intel in present day world, each core is hyper-threaded with 2 threads. So if I have a CPU with 4 cores, it means I have total 8 threads. I can run 8 processes in parallel. Right? So this is very important to understand from a performance point of view. So I will always have more RAM memory, a good hard drive with RAID, multiple core CPU, multiple network cards, so that if one network card fails, the second one can take over. Or if all are working, I will get a better throughput. Similarly for secondary also, right? I will run it with a good configuration so that in case I have to fail over, it should be able to handle the load. On data nodes, I do not need to configure RAID. Why? Because already it is replicated 3 times. Whatever I copy, it's replicated 3 times. I'll be using obviously 64-bit operating systems. Why? Because in a 32-bit system, the maximum addressable memory is only 4 gigabytes. So I will go for 64-bit systems. And I will always prefer multiple disks rather than a single disk. So let's say I go to market and I have a choice. I'm building my data nodes. I have a choice between a single hard drive of, let's say, what is the number here? Let's take the same number. Okay, 2 into 6 of 12 terabyte. I have one single hard drive available of 12 terabytes. Although it's not available currently in the market, but I'll give an example. Second choice I have is I take 6 hard drives, each of 2 terabyte. Right? I will go for this option. Why? I will get a better performance. I will have much better distribution. Why much better distribution? If you have ever looked inside the geometry of your hard drive, there's a disk platter, right? And you will have a head, both on the top of the platter and underneath of the platter. Something like this, right? So what it will be doing, it will be reading both from the top and the bottom. So more number of platters I have, more parallelism I will have. Means in one seek of my head, this is head, this one is head. In one single seek of head, I can read more blocks. I can read more blocks, more sectors I can read. So also important thing to keep in mind is, let's say this is my disk platter. It will have tracks on it, similar to a racing tracks, right? Each track will be divided into smaller sections, right? Each will be divided into smaller sections. This area is called a sector, which is standard 512 bytes. Sector size is fixed. The size of sector is fixed irrespective of whatever hard drive you buy. Hitachi, Samsung, Omega, Seagate, does not matter. But what varies is how many sectors I will have per track. How many tracks I will have, 1, 2, 3 or 10 per given unit area. So what does it mean? In addition to having multiple hard drives, it is also important to have hard drives from the same vendor. If you are using Seagate, use Seagate. So in your organization you might have seen, because all your hard drives will be supplied by the same vendor, because you will have a contract with, let's say, IBM, Dell, somebody. So all your hard drives will be from a same manufacturer. But the reason is also performance, because each hard drive vendor will have a different geometry. Geometry means different density. Someone might have, let's say, 100 tracks per disk, per platter. Some might have, let's say, 2000 sectors per track. Some might have just 1000. But this size is fixed, standard. Sector size can be 5, will always be 5.2 bytes. But rest can vary according to your manufacturers. So always use same hard drives. So you will have better parallelism. Correct? Very important. Have more number of disks from the same vendor. Solid state devices. They do not have any rotational parts, SSDs, right? But the cost is very high currently, right? So this is a drawback. Buying a 2 terabyte SSD will cost you approximately the price of your system, right? So currently we will not be going, but in future, yes, we will be using SSDs. So The important thing is your name node should have good memory so that entire metadata can sit into it. It should run on a good hardware. It should take care of failures. For example, name node is a single point of failure. I can afford to fail data nodes, but I cannot afford to fail a name node or a job tracker or a secondary name node, which are masters. So I should make sure good hardware. Right? Similar for any of your masters. Secondary is a master, job tracker is a master, everything is all the master nodes. Okay. So now, how you will plan your cluster growth? So let's say your data is growing at 5 terabytes per week and you have set up replication 3. So what does it mean? 15 terabyte of space you will need every week. So if your data node has 5 hard drives of 3 terabyte each, so it means every week you need a new system, right? So every week you need a new system. It does not mean that every week you will go to market and buy a system or order a system with your vendor. You will plan, let's say for 6 months or 1 year, you will order them in advance and keep your cluster ready. This is how you will plan it. So on slave nodes, have multiple hard drives as I showed you. Do not put them into RAID because already they are replicated 3 times. Run with multiple CPU cores, run with good memory and multiple network cards. Right? This is how your RAM or your data nodes will be. So now the question comes, on my data node, what will happen? Let's go to the scratchpad. Let's say I have a data node with 4 gigabyte memory, right? Making an assumption that nothing is used for operating system and other things. So let's say entire 4 gig is available for my MapReduce. So by default, each map task takes 1 gig of memory. By default, right? Similar to block size, similar to replication, map memory is defined 1 gig. It's a configurable parameter. Reducer takes 1.5 gig. So if I have a system, a data node with 4 gig memory, I can run 4 mappers or 1 mapper and 2 reducers. Right? So I will decide on, depending on the total memory I have, how many mappers and reducers I can run. So in addition to that, what I should do, I should make sure that there is no swapping or swapping. Let's say I have a memory which is 2 gigs. Let's say 2 gig memory. On my hard drive, I configure certain part of my hard drive as swap space. I have to make sure that swapping does not happen for my Hadoop demos. So I have to make sure whenever I'm running anything on my data node and I know what is the memory, I should make sure not more than that many mappers or reducers run on that node. So it should never swap anything to the disk. It should not write anything to the disk. So now you have to ensure that the memory should be sufficient to run your nodes, all your daemons, without doing a swapping to disk. Another thing is the total number of tasks you can run will be equivalent to the number of 1.5, the number of cores. For example, what does it mean? Let's say I simply just now said that if I have 4 gig of memory, I can run 4 mappers, let's say 4 maps, because each map takes 1 gig. correct? But can all these 4 maps run in parallel or not? It will depend upon how many CPU cores I have. So if I have a CPU, only a single CPU core, irrespective of how much memory I put, instead of 4 gig, I may put 14 gigs. I may run 14 mappers. But if I have only one CPU core, I can run only one mapper at a time. So having large memory will be waste if my CPU is not there. So always put multiple core CPU, so that if I have 4 gig of memory and if I'm running 4 mappers, all 4 can run in parallel. Right? So the rule is how many tasks I will ever run on my CPU. So task means, what is a task? A map, a reduce is a task. Job is your entire job cycle, which is the combination of your mappers and reducers. But each part of your job, map and a reduce, each one is a task. Right? So how many tasks I can run in a CPU? It is 1.5 times the cores I have. Why this is so? This has to do with the load. Let's say if I go to my Linux system, currently I do not have that much load, but if I execute the command uptime, it gives me 3 parameters: 15 minutes, 5 minutes, 1 minute load. So what is exactly load? Right? Although it's a very complex thing at the back end, but simply load is, let's say if load uptime command shows me load as 3, and if I have the 2 cores, what does this value 3 means? It means that there are 2 processes, each one occupying a CPU core, and there is a third one in the wait queue. Third one is in the wait queue. So as soon as any one of these two finishes, the third one will run for the CPU. So the formula is, I can have 2 processes occupying cores, 1 waiting. So on a 2-core CPU, I can run 3 processes. So 3 divided by 2 gave me the formula 1.5. So there that formula came from. So I will always run 1.5 the number of CPU cores. Let's say if I have 4 mappers, 4 maps, and I have 4 gig available memory, but my CPU has only 1 core. Right? So what will happen? The time will be divided between 4 maps. Right? So time slicing will happen. So let's say if this is a time window T, each one will get certain time. Right? All 4 will not execute in parallel. So it will take much longer. Okay. Now, next point. Similarly, the disks which I talked about, always go for larger disks. Do not go for 2.5 inch disks. One is they're expensive. Second is their access speed, means rotational speed will be less. Right? So I think this is quite common physics. Let's say if you have a wheel of a bicycle or any motorbike, right? The outer arc of your wheel will be having a higher angular velocity as compared to the inner ones, right? So same logic. So the more the diameter, faster the disk, or faster the rotational speed at the outer circles. always have multiple disk drives rather than having just a single drive. So if you look at process states, right, your process, let's say process P, can be in different states. It can be in running state, it can be in waiting state, it can be in zombie state, right? So there are different queues, right? There will be a running queue, there will be a waiting queue. So let's say you have CPU. So when a process runs on a CPU, according to a scheduling algorithm, so what scheduling algorithm does? It picks the jobs from a queue and schedules it on the CPU. Where it picks from? It picks a job, puts it into a running queue. You will have different queues, right? So it will pick up a job, put it to the running queue, give it some time slice, then it will put it back into the waiting queue. It pick up from the waiting queue, put into a running queue, and keep on running. It will keep on doing time slicing. So if you do PS command on your system, at any time you will see only one process running, other you will see in waiting state. So now the question comes, how much data I will put on one data node, right? So I explained you the logic. I explained you that I can have 1 terabyte coming out of from one hard drive, one data node. I can have same data coming out of 4 data nodes, each having 250 gigs, correct? Total number of objects remain the same, but which one will be better? Either to go with one system or 4 systems. Obviously one system will not be good. If it fails, I will have outage. To have multiple CPUs is a better thing. But now the question comes, how much data I should max put on one data node? Can I put 100 terabyte on one data node? Right? What will be the disadvantage of putting too much data on one data node? So obviously I'm not talking in terms of whether my hardware supports it or not. Right? I am not saying whether my motherboard has that many SATA slots, whether I can connect so many hard drives or not, right? So let's say that is there. What will be the, how will I say? Technically, I might be able to put, let's say, 100 terabyte on one disk, one data node. But whether it will be the right thing to do or not. So let's understand. Let's say if I put 100 terabyte on one data node and this data node fails. What will happen? I have more data to fail. I have 100 terabytes of data to fail. Let's say other case was I had a data node with 1 terabyte of data. Now I am failing 10 terabyte here. But if I have 100 terabyte, I am failing 100 terabyte of data. So the replication which will be done will be higher. The replication storm or the network traffic which will be generated will be much higher. So I should not put too much of data also. Technically I might be able to do, but I should not do. Because if that data node fails, I have more data to fail, more will be the replication storm, more data will be copied across my network. So it will increase my network bandwidth. So I should avoid that. So this slide is a little bit old, which is saying 24 terabyte, but now we say around 40 terabyte per data node is good enough. Right? 40 terabyte is manageable. Okay, now we will not use RAID on slave because we know redundancy is 3, replication is 3. Also, I will be wasting a lot of space. If I start using RAID on data node and again doing a replication there, I will be wasting space. Because by default what happens whenever I put a RAID, let's say put a RAID 1, my total capacity is reduced by 2, divided by 2. I have 2 disks of 1 terabyte, total is 2 terabyte, but only usable is 1 terabyte because both are acting as one unit. So whatever I have will be divided by 2. Now on top of that I am doing replication into 3. So total space is now divided by 6. So if I buy hard drive of 2 terabyte or let's say 2 hard drives of 1 terabyte each put into a RAID, my total available usable space will be divided by 6 in Hadoop. So I will not do that. Right? Second, in a RAID, the speed of your RAID is decided by the slowest disk. What does it mean? Let's say in a RAID I have 4 disk drives in a RAID. This one is the slowest disk, let's say. This is, let's say, 50 Mbps. This one is, let's say, 10 Mbps. This one is 50, this one is 50. This one will be deciding my performance because this is the bottleneck in a RAID. But in the case of a JBOD, JBOD stands for just a bunch of disks. Each disk works independently of the other. So my total speed will be average. Let's say this is 50, this is 50, this is 10, this is 50. So 160 divided by 4 will be my average speed. Right? So I will always go for JBOD. On master, I will always put a good hardware as we discussed because they are single point of failure. But data nodes, they are designed to fail because we have application 3, so I can afford the failures. So on my master, I will not use commodity hardware. I will put a carrier class hardware. So we have 3 classes of hardware. Enterprise class, carrier class, commodity class. 3 classes of hardware. So I will go for carrier class. I do not need still I do not need that expensive enterprise servers or let's say mainframes, dome servers, all those, but I need a decent hardware. I need dual power supply so that if one power supply fails, the second one can take over. I need multiple network cards. I need RAIDed hard drives on my masters. Similarly for networks, I will go for dedicated networks. What does it mean? I will not use the Hadoop network to pass any other traffic. I will configure separate VLANs. I will make sure the network switches where they are connected, they have good speeds. Right? So what does it mean? I will have a switch, let's say 4-port switch for example. I have 4 data nodes connected to it. Right? This switch will not be used for anything else other than Hadoop traffic. Let's say I'm running a company which is doing video streaming also. I will not use this switch to pass any of the data from any other network. Right? I may have a network which is having, let's say, video streaming data going. I will not connect into the same switch. I will segregate them so as to have different networks. Also, I'm not sure how many of you are from networking background. We do a lot of performance tuning at the network level also. So by default, MTU of your net is, we say 1500 bytes. The largest packet which can go onto your interface. But in the case of Hadoop, we set it to 9000. We called it as jumbo frames. Right? All those things who are interested to do a deep dive, they can read the documentation, right? Jumbo frames. We enable jumbo frames. So what happens is, my name node, data node, they will have multiple network cards. So here you see multiple lines coming. They will not have single line, single interface. So whenever I configure more than one NIC card to behave as bonded interfaces, this protocol which gets enabled by default, which is called LACP, link aggregation control protocol. I do not have to configure anything. So what happens is, the moment I configure, let's say if I do if config here, currently I see only ETH0. But let's say I have more than one interface in my system. Let's say I have ETH0 and also ETH1. I can combine these two to make one interface. I will call it as bond 0. So what will be the advantage? If this is running at 10 Mbps, this one is also running at 10 Mbps, my total throughput will be 20 Mbps. And if one fails, I will not have outage. Although the performance has gone down, but so this is what we can do in our real production environments. Similarly, for the switches also, I will combine ports of switches to work as one, so as to have better throughput. So a cluster with more nodes perform better than one with fewer slightly faster nodes, right? Absolutely correct. So better to have more number of nodes rather than having a single powerful node. Slave nodes should not be using virtual memory. Okay, it's a typo. It's not RAM, it is virtual memory, right? It should not be using your virtual memory. It should always be running from your main memory. Which of the following provides redundancy by replicating blocks across multiple nodes, right? Which provides the replication across multiple nodes, name node, data node, or HDFS, right? So it is a feature of your HDFS file system. So when a client wants to retrieve a file from HDFS, it consults always the name node, right? Because it is the master. So we have already seen passphraseless access, how you will set up that. Passphraseless access means I can do start stop from my name node, and my entire cluster starts or stops. Similarly, in terms of software, what I need Linux to run production clusters. Although this is supported, but Windows itself has high memory requirements and CPU requirement, so it is not preferred. So either you will run RHEL means Red Hat Enterprise Edition or CentOS. Some companies also use Ubuntu. Java, I will always run minimum 1.6 JDK. Right? Why? I think I have explained to you. Not sure. Okay, let me explain it again. I can run OpenJDK also, which comes by default with my Linux. But why I do not run OpenJDK? Two reasons. OpenJDK, two reasons. One is, I told you that JPS command is not available. It is available only from versions 1.6 and higher. But the main reason is how the JVM forks. In OpenJDK, how the JVM forks is, let's say I have given heap size in OpenJDK as 1 gig as heap size. I submit a job. It will fork a new JVM to run that job. So when it's forking a JVM, it does a fork call, F-O-R-K, fork. It creates a new JVM. It will also allocate the same memory, 1 gig. The moment the fork happens, right? After that it will reduce, but the moment the fork happens, it will look for the same memory. So if by is not 2 gig available, it will fail. So my name node will kill or my data node will kill wherever I'm running that. So that's why I'm not running OpenJDK. We go with SunJDK. I will have some operating system utilities like SSH we have seen, cron jobs, rsync, NTP. NTP is network time protocol. So why network time protocol important? I should be running my entire cluster with the same time. Means, let's say I have 1000 nodes, all 1000 nodes should have the same time. Why? It will be easy for me to troubleshoot and also the communication. Right? It should not be, let's say I'm troubleshooting node is data node has time 10 p.m. It is connected to, let's say, name node which has time 4 p.m. I will not be able to figure out in the logs when an event happened. So I should keep time synced. Also, there are many services. For example, Zookeeper, Coordination, Kerberos, they will not work if the time is not synced. All the nodes should have the same time. So I will run NTP. NTP is Network Time Protocol. NTP. In a production environment, I can use any of the Hadoop distributions. I can run Apache Hadoop, which we are seeing in our course. I can run Cloudera, I can run Hortonworks, I can run MapR. Right? So all these distributions are there. So Cloudera and Hortonworks, they are entirely open source. You can go to Hortonworks site, download their version, use it in your production environment. You have to pay only if you take support from them. But MapR is not like that. MapR you have to pay. It is a proprietary thing. So now what is the relationship? So what happened? Hadoop originally, okay, let me clear it. Hadoop originally came out of Yahoo. It was contributed to Apache Software Foundation under the license Apache Distribution License. So what does it mean? Anybody can go download a Hadoop, modify it, build tools on top of it. So what happened? This Apache Hadoop, which we are doing today, it was taken by many companies. Cloudera, Hortonworks, MapR, other companies like Pivotal, Intel, IBM has their own version, right? Which they called it as Big Insight something. So what they did was, what Cloudera did was, Cloudera is purely open source, right? They are taking the same Apache which we are doing. But what they have done is, they have built a graphical tools on top of it, GUI. So that, let's say in an enterprise, I may not have a Hadoop team. Companies like Yahoo, Facebook, Google, they might have a Hadoop team. They can afford to build a Hadoop team. They have time with them. They are technology companies. But let's say what about banks? They cannot invest into building a Hadoop team. So what they do, they are looking for ready-made enterprise solutions. So what Cloudera did, similar to Cloudera, Hortonworks, MapR, what they did, they built tools on top of it. So that you just click using a graphical interface, it will deploy a Hadoop cluster for you. But what MapR did in addition to what others did not do, MapR from the very beginning, they took this Apache Hadoop, modified certain code, built some features. For example, they removed name node. Name node is not there in MapR. Right? They built a lot of things like NFS, which is not available in Hadoop. NFS came recently in Hadoop 2.0. It was not there. So what MapR did? Now currently how we are accessing Hadoop file system? I have to do Hadoop fs-ls, right? I have to do something like this command. But in the case of MapR, I can simply do ls-l. I can use the same file system commands because it supports NFS. I will mount my Hadoop as NFS. So on a Linux box, it will not matter to me whether file is on HDFS or local file system, because I can export my HDFS and mount it as a local file system in MapR, right? Not anywhere else. So others have started supported recently from Hadoop 2.2 and all. So now let's look at what MapReduce, right? So we have talked a lot of things about what it say, HDFS, name node, data node. Now let's look at MapReduce, right? What are MapReduce? What are the schedulers? What they do? Okay. So now let's quickly go to a system and configure it. Let me start a new. Okay, we have a new node. Okay. So now I have my cluster up and running. If I do GS here, I can see name node is running and I can see data nodes are running. My data nodes are running. Right? So now let's bring a new machine. IP 69. What is this machine? This we will configure as, I have given a name JT. We will configure this as a job tracker. So what is the difference? cd hadoop config vi core -site. Same thing, it should know where name node is. vi -site blank, because it will not store any data. It is neither a name node, neither a data node. I can keep it blank. Now, two new files comes into here. vi mapped-site. Okay, I will open this file. Let me remove all things which we do not need. Right. So all this file will be blank in a real case, but let me remove this. So what I've done, in mapped-site file, I will make an entry. I will make an entry saying mapped.job.tracker. I'm saying where a job tracker will run for my mapper. I'm saying jt.cluster1.com, this port. Which is JT node? The node itself. Right? Same thing I will copy and I will put on all data nodes. vi I will go to each data node. I will put that on. cd hadoop config vi mapped-site. I go to each data node and put this entry. So what we are doing? So on data node, we have two files, important file. One is core, which is telling data node where name node is. Another file is mapper, which is telling where is the master for my job tracker, for my MapReduce, which is job tracker, JT. So I say vi mapped cd hadoop config vi mapped-site. So I open this, copy this. So now I went to each data node, opened the mapped-site file and made an entry. Save the file on each of the machine and on the job tracker also. ls-l. Simple. I will say hadoop-daemon.sh start job tracker. Right. So now on the data nodes, what I will say, hadoop-daemon.sh start task tracker. So now task tracker is a client of job tracker. Right. It's a slave of job tracker. So I will start this on each data node. So now my entire cluster is up. Name node is up, data nodes are running, both data node and task tracker, and I have one master which is running job tracker. I have another master which is running name node. But data nodes are slave of both name node and job tracker with their respective components. Correct? Now let's go to client now. In client also I have to make the same change. vi mapped-site. I will go here and I will write the same entry here. I'll write the same entry there. On the client machine, I am also telling where the master for my job tracker is. correct? Now let's run a MapReduce job. So I'm sitting on client. Hadoop fs-ls. I have something there, right? So let's say I create a input directory, mkdir, to keep things tidy. I create input directory. Let's say example word count. Right, I'm sitting on client. Let's create a file, word count .txt. I write something. This is a word count example, right? And I copy this, and let's say I write it few times. So I have a file word count which has around some lines. I copy this file, Hadoop fs, put word count where? Into input directory, right? So now I say Hadoop fs-ls/input. So I've copied that file into input directory, right? So now let's run MapReduce. So ls-l Hadoop, you have a lot of jar files which are given to you with your Hadoop distribution. So there's a jar file called examples, right? So let's say I say Hadoop, how I run any MapReduce command or a MapReduce program, Hadoop jar and the name of the jar. If I hit enter, it will tell me what all programs you can run by using this jar, right? All this I can run, right? So we'll see a lot of things out of this, but let's say I'd say word count, right? So I will say word count. I'm saying I want to run word count program. So this is a jar file I'm calling a class, word count, on which I'm saying on input directory, and write an output to output directory. I'm saying this. I'm saying run a MapReduce job which is word count on input directory, route data into output directory. It will run MapReduce job for me. So if I go to any system, I can say Hadoop job -list. It will list me the jobs. I can kill a job also by giving a job ID kill. But let's see what it is doing. So it is running map and reduce, map 0, map 100%, then reduce click. So once the map completes entirely, then only reduce phase will kick. So now the job completed. So it is telling me parameters like how much data it read from HDFS, how much it wrote, what phases it ran, right? So we'll see all this in our performance, what all these values are. So I can access this from my browser also, 192.168.1.69:50030. Right? So it is saying I have 3 nodes, and it's saying me I ran one job. So this is the job which I ran just now, right? So where it wrote the output, Hadoop -ls, it will create an output directory. Inside output directory, you will see it will have that part. Right, so it is telling me how many times each word happened. So this is what MapReduce is, right, in simple terms. So we'll see a lot of examples as we go along, right? So this is running MapReduce. So I cannot, let's say, if I run this job again, it will fail. Why? It is saying output directory already exists. So in Hadoop, I cannot override. So I have to give a new name. I'm saying output 1. I run it again, it will start running. So I again go to any system, I say list, it will list me the jobs. It will list me only the running jobs, right? If job completes, let the job complete. If I run this list command again, it will not show the job. So for that I have to do all, right? I do not need to remember any command. I simply do hit here. I can see the commands, right? I can give status and a job ID. If I want to look what is the status of a particular job, right? It will tell me the status, right? So now the job completed. Like let's say if I run this command again, list command, it will not show me. I have to say all. It will show me the completed jobs also. Shrikant is asking, did configure task tracker along with JT? What we did was, on JT we made just this entry into MapReduce -site file, right? In MapReduce -site file, I simply made this entry. This entry I copied on all of the data nodes. In MapReduce site. So how we configure job tracker? What we did in the case of data node, I just pointed data node to name node. So here also what I did, I just pointed a task tracker, means the data node, MapReduce-site file to JT file. I just told it where your job tracker is running, and I started the task tracker demo there. So it started talking to it. No, we don't have to. So Arjun is saying a file with 2 blocks of 64 MB, if processed by a mapper, then a reducer, default option, then mapper will consume 1 gig for the first block, do its job, release it, and reoccupy it over there. Okay, so he's asking in terms of execution. Okay, so what he's saying, let's say I have a file whose block is 1 block. File with 1 block, 64 MB. So by default, each mapper works on 1 block of HDFS. So, right? So let's say if I have a file which is split into 4 blocks, I will have 4 mappers assigned for it, 1 for each block by default, right? How much memory will be given to each? 1 gig, right? 1 gig will be given for 64 MB, although it's not optimal, but default it will be like that. So larger blocks will be better. If my block size is, let's say, 256 MB, this much will be handled by 1 mapper using 1 gig of memory. So the number of mappers which will be for a task will depend upon the splits I have for a file. So if a file is split into 2 blocks, I will have 2 mappers. Default, right? I can change by a program, not through a parameter. I cannot change this through a Hadoop parameter, but I can change it through our code. I can say, although my file is split into 2 parts, but I want only 1 mapper to be assigned to my entire file. Instead of saying mapper assigned to per block, I can say mapper assigned to my entire file, right? So I can do that. So now, what happens is, whenever I submit a job, it goes to job tracker. Whenever I submit a job, it goes to a job tracker. So job tracker has a queue, which is FIFO by default. First in, first out. Whoever submits the job first will get to use the cluster first, right? This is the default behavior. So what happens, let's say I am the user, let's say user 1 comes, U1 comes, he submits a job, and it goes into the very first slot in the FIFO queue. Now user 2 comes, his job will go and sit in slot 2. Now let's say the user 1's job takes 10 hours to run, but user's 2 job needs only 5 minutes to run, but it's a FIFO. So user 2 has to wait 10 hours 5 minutes for his job to complete, because he is sitting behind a job U1 which takes 10 hours to finish. So this is the default behavior, FIFO, first in first out. Whoever submits the job first will get to use the cluster first, right? So this is not good for production, because when I'm running a large production cluster, I do not want something to happen like this, because in this case I will be wasting my cluster resources, because I'm setting up, let's say, a 100 node cluster. This I have 100 node cluster, 100 nodes. So I will not be using my cluster optimally if I'm using FIFO, first in first out. So this is not used anywhere in production, but this is the default behavior how Hadoop started. So what is the other way? I have 2 more schedulers, fair scheduler and capacity scheduler. So FIFO is first in first out. Whoever submits the job first will get to use the Hadoop cluster, but this is not used in production. So fair scheduler came into picture. So what fair scheduler does, it allows you to use your cluster on the same way how operating system does. How operating system does time slicing between different applications, similarly fair scheduler does time slicing. So it will give you a fair share among different jobs. So it allows the longer jobs to exist with shorter jobs. So you can use your cluster more efficiently. Right, so this is what fair scheduler is. So we'll see all the schedulers in detail as we go along the course. So, but the basic idea of scheduler is, let me explain you on the slide. What does fair scheduler does? So let's say I'm in a Hadoop team, right? So I have an ask for, say, setting up a 100 node cluster. Let's say I have 100 node cluster. So I will ask financing. I will say, please sponsor me a cluster. So different business units will come and they will say, okay, we will sponsor. So let's say marketing team comes and it says, we will sponsor you 20 nodes. Finance team comes, says, we will sponsor you 30 nodes. R&D team comes and says, okay, we will sponsor you 50 nodes. Right? Everybody has sponsored me few nodes. So now this sponsorship is not even. Somebody has given me 50, somebody has given me 30, somebody has given me 20. So let's say I'm running a Hadoop cluster, right, with 100 nodes. So now I cannot share them the equal resources, because now R&D team has given me the most number of nodes, 50. So I will give them guarantee. I will say, I will give you, let's say, 50 mappers. I'm just giving a hypothetical case, and 50 reducers anytime. I guarantee you that. To finance team, I will say, I guarantee you 10 mappers and 10 reducers. Right? I'm giving them a guarantee. So I will define pools. I will say pool A is for R&D team. And in that pool A, I will say 50 mappers, 50 reducers. Right? So let's say my total capacity of my cluster is, I can run, let's say, 100 mappers. Let's take an example. I can run 100 mappers at a given time in my entire cluster. So I will say pool A, pool B, for example, let's say I have 2 users, marketing and finance. To marketing, I have guaranteed 50. So 50 are left. So pool B comes, he can use the remaining. But let's say a third user also comes. To R&D I have granted 50. A user B, this is user A, this is user B, this is user C. They are using 30-20. So what is happening? Guarantee is for R&D team. Rest all will share. Let's say if user C goes out, user C moves out, what will happen? His 20 will be given to B. Right? So what is the case here? If there's no user using my cluster, he can use 100%. But if somebody comes in who has been guaranteed some usage, let's say R&D team has been guaranteed some usage, 50. So he will be, his 50 slots will be taken out and given to R&D team because I guarantee them. So this is what fair scheduling is doing. I guarantee them the slots. Right? I guarantee them slots. If no else user is there, I can use the entire cluster. But if another user comes, I have to give them the guaranteed slots and I will be moved back. I will be moved down. Moved down to what? To my share. Right? Not lower than my share. So what does it mean? Let's say A user is guaranteed 20, but he is currently using 30, let's say. And another user comes in B, and he is, let's say, guaranteed 10. So, but I do not have any other space. So what it will be done? 10 will be taken out from him and given to him. He never go below 20 because 20 is his guaranteed quota. Right? So this is all done, taken care by fair scheduler. So we will see all this as we go along the course, how we will set up this. So how we enable fair scheduling, how we set up, how we configure parameters, right? All this we will see. So for the time being, for food for thought for you is how we will enable fair scheduler. I will simply go to mapper side and I will enable a fair scheduler. I will go to job tracker, right? Whoever is master, I will open the mapper file and there I will make an entry. I will enable fair scheduler. By default, it will just use FIFO. I will save the file, restart the daemon, fair scheduler is enabled. Then I will go and configure my pools. So we will see all this in our upcoming sessions. So we can assign pools, we will submit job to pools, and we will see how we will submit jobs to pool. So currently what we are doing from client is, I'm simply running a job. I'm simply running a job. But once I configure a pool, my command will change. Here I will say -d pool dot name is equal to pool A. Right, whatever my pool is. So I will be submitting a job to a specific pool. So depending upon the capacity given to a pool, I will be given mappers and reducers. Okay.